So at least 2 licenses is fine or 3 is required.
I think 3 because if
Yeah,
we start to
multiple.
use it, if we start to use it,
Okay.
so that it doesn't hold us back.
Sure. Yeah.
So what example is this?
I just created one, David,
Okay.
so that I can explain what we did last time, and
Okay. Yeah.
I'm gonna add something more.
Okay.
Let's wait for 1 minute if somebody wins, and after 12:03 you can start.
Okay.
So looks like you cannot cover the dam breach and then other items. Maybe you need to request another lodge and learn Solomon to.
No, it is here.
Oh, it's covered. Okay,
Yeah, it is
that's
here.
good. That's good then.
If time allows, it is here. I put everything in one example.
That's good. That makes sense. Saves time.
Yeah.
Uh, okay. Good afternoon, everybody. This session is for the flow splitter, splitting the flow, taking some flow to the storm water management facility and leaving the rest to go to the offsite area, and also do some dam breach analysis. These are the very important topics in water resources. Recently, we have a HydroCAD purchased. So HydroCAD has a capability. Solomon is going to demonstrate, do some workshop based on a dummy project on those 2 items. So welcome abroad for the workshop. And then Solomon, go ahead and start the presentation or workshop.
All right. And welcome everybody. Like what we did last time, I'm gonna repeat something to start with. So here I have some subcatchment, and if I edit it, it's gonna show me the land use for each, soil group, and it is here, pavement, woods, and grass, and corresponding curve number. So if you want to add some more area, you have here the curve number which you can use, and of course the area here. And then for this area, you can use either here. This button is for to put the area in acres, but I'm using, as you see here, square feet. But if I click here, it's gonna change it into acres for me. So, and then it's gonna, of course, calculate the weighted curve number for us. So after that is the part for time of concentration, what we did last time. Again, sheet flow A to B, the corresponding Manning's, value based on what kind of surface we have, and then the flow length and the slope you put here, and you're gonna use the two-year rainfall depth, which is in this case 3.16. That is for calculation of the other values like velocity, and of course shallow concentrated flow, and then I have some pipe flow here. That's how you do it. If you don't want to do this, you can just put time of concentration by directly putting how much time you have or you want to use. But here I put it in. I just use the calculation based on the TC paths configuration. After that, you are done with the subcatchment. And here I have a catch basin, which I directed the subcatchment to catch basin because I want to divert some amount of flow to the ESD facility, which is smaller, and to some pond, the leftover, so that it can be like a quantity treatment or something. So here I have the diversion practice. The way how it works is I'm gonna share here another stuff. Can you see this, my PDF?
Yes.
All right. So the flow comes in here, as we said last time, which means from the subcatchment, it is coming here and gonna be stored here. No, it's not storage, but it's gonna stay here until it reaches the elevation of this weir. And the elevation of that weir, I'm gonna show you how to set it up. So this 4-inch pipe is gonna direct, which means this one is gonna direct the flow to the, let me check, to the ESD facility. And this 15-inch pipe is this one is gonna direct it to this pond. So the way how we configure this thing is this weir is we're gonna have to calculate the water quality volume first for that ESD facility. We're gonna calculate the water quality volume. I have some calculation here set up. So we're gonna change that volume into a discharge. The way how we do it is uh, this is a drainage area, change it into a square mile. And this is the water quality volume converted into watershed inches. In my case, it is 1 inch, but we can use up to 2.6 inch because if we want to provide more than water quality volume, like ESD to MEP, I think we can use up to 2.6. But here I have 1 inch, and the corresponding peak unit peak discharge is 836 for that. But if I change it to 2.6, then it changes for me here. This is a normal TR55, spreadsheets which I use. So I use it to generate that unit peak discharge for me. So this QP is the discharge which I want. This is a discharge which corresponds to the water quality volume, which I calculated somewhere based on 1 inch or 2.6 inch. The RVQ is equal to some form. We have some formula to calculate the water quality volume, and that volume will be converted into a discharge because that is the discharge I want to divert using that divergent structure. So based on that, the drainage area, this one, the unit peak discharge, and the water quality volume represented by the, converted into watershed inches. So again, if I want 1 inch, look, it's gonna update for me, but I can share this with you guys if you need to, if you want it. So this is 1 inch water quality volume inch, change it into watershed inch, and this is a corresponding unit peak discharge, KVU, and then this is calculated. It calculated for me the discharge corresponding to the water quality volume. Once I know the discharge, I'm going to here, I also have prepared something here, the orifice flow regime. I have 1.1 CFS. So I'm gonna come here and corresponding based on what the size of my pipe is. I don't know how I set it up. Let me see here. So the orifice, this one is gonna be 36 inch. And then this one is gonna be 4 inch. So I have 4 inch. This pipe is 4 inch. So I'm gonna come to my orifice flow computation for 4 inch. This is for 4 inch. And I'm gonna find the flow 1.1 inch. I mean 1.11 cubic feet per second. So where is that? I don't have it here even, you know, that, I mean, I have to change, these are the heads required. So if I change it to 6 inch, that pipe, it's gonna be for me, I think this head I need for 6 inch pipe. The head will be 1.4 feet, corresponding to that 1.1 CFS. If I use 6, I mean, I think I have to use 6 inch pipe because the discharge is 1.1 CFS. So once I know that head, a required head for 1.1, it is, how much I said, it is 1.4 feet. So I'm gonna say I'm gonna come here and let me show also this. So, and at the outlet, you, wait, is this happening here? I just want to keep this. So for this is a primary 235 inverts, and the 230, it is primary. That means it's going to the primary, and these are the inverts, 235 and 234. Invert out, and this is the length, and then of course it calculates for me the corresponding slope and then the size, and that's gonna be number 1, which is this. I even set it up as a large pipe, 36. That is a diversion. And then for the other, I set it up at 4 inch, as you see here. It is vertical. Its invert is 235. Vertical means on the vertical surface, and it is secondary. It is independent of that primary. It is secondary, which means that this one is going to be dependent. I mean, this broad crust, the weir is going to be routed to this orifice. That's how we set it up. So 4 inch diameter, it's going to secondary, and that secondary is going to be, and this is a weir crust, the broad crusted weir, which have invert 236. It depends what bottom elevation of that catch basin is. I just set it up at 236, but we need to take account of that that head 1.4.
Solomon, is it so what we're
Yes.
trying to do here is, right, like, so the pipe, what was it, 36-inch pipe, we don't want that to start flowing until the water gets to what elevation, 36, which
yes.
will be the weir.
Yes.
Is it gonna do it this way? Is it like if we set it up this way, does it know that? Because I don't see how it would know that the water needs to overtop this weir before it goes to the culvert.
Because of this, you know, this is by itself. The culvert is by itself. But this orifice is gonna control, gonna route to this broad crusted weir.
But wouldn't, like, I mean, maybe I'm wrong, I'm not sure, but wouldn't the weir need to route to the culvert or something?
Yeah, that's what we are doing. That's what we are doing. You see, device 2 means that
So
orifice.
shouldn't it be like to device 1?
Or
We can
yeah,
do-
is the culvert device 2 or something?
No, so
No,
the
no, no, no.
culvert,
This
so the
is the
culvert
number.
is
You see,
device one,
1, 2.
right?
Oh, you are saying maybe I can change this to into 4-inch then if you.
I mean, whichever way, but
Yeah, but
So
the
okay,
based.
so we're saying is for the wheel,
Yes.
okay?
Uh-huh.
How did it know where it's routing to?
Because
Right,
of this, you see, this
device
weir
two.
this weir is going to device 2. Device 2 is, this is a number, 1, 2, 3. Okay,
so should
And,
it go to
and,
device 1 then?
we can do that
Or
too if we want to.
yeah, I guess that
You
would
can change
match
it.
the sketch you
Yeah.
have if it goes to
Yeah,
device
I just
1,
set it
but
up like this, but if you edit it, you can change it here to device 1 also. Yes. Okay. So
so
that means
so
that
that's the,
means yes.
so does that mean that
Now the
that
culvert.
whatever water is coming out of the culvert will hit the wheel first?
No, it goes to here. It goes to here because this, I mean, this culvert is controlled by this now, the elevation, I mean, the crust elevation of this. Let me,
Just go
the
back to
way
the
I
drawing.
so the flow is coming here. So before it goes this way and goes to this, it's going this way to that 4-inch pipe.
I'm
And
wanting to
then,
4-inch pipe.
yeah,
Okay.
to 1. Regardless of this, I mean, because once we fill this up to here, up to this 1 point, I don't know how much is that, but this is the height of this wheel is gonna be set by the calculation how much volume we're gonna it says 1.4, so it's gonna be 1.4 above.
Okay.
Uh,
Okay.
so this is gonna be the height of this is gonna be from here to here is gonna be 1.4 feet. So it's gonna fill here. It comes in. It's gonna fill up to 1.4 feet, and it goes this way toward our ESD facility.
Right.
But once it fills, it's gonna overtap and go to the
To
uh
the culvert.
the culvert. Yes.
And
So
that's what
is
it's saying. Okay.
so is number one our primary outlet?
Yes.
Then that should be our 4-inch pipe, right?
Yes.
So number two is the bigger pipe.
The bigger pipe. Yes.
Okay.
Yeah. I mean
Okay.
the size doesn't matter.
No, I understand. So one number one is the one that takes the water quality volume to the EST
Yes.
facility,
Yes.
and a number two is the bypass.
Yes.
Okay, so if you go back to your HydroCAD, number one, that's primary.
Yes, I think I set up this. I'm gonna change it to 6 here. That is what is
Yeah, so that's
creating
that
the
should be
confusion.
your yeah, the smaller pipe.
Yes, and then for this one, I'm gonna change it into, let's see, 36.
So this is not your orifice then. The description you have there, it's confusing.
It's gonna be Calvert, yes, but
Yeah, so the number one is the orifice or yeah, grades, whatever you want to call it. So number
yes,
two is going to be the outlet pipe or the culvert.
yes, yes. So I can edit it. Uh, I think I have to delete it and change it, but the idea is this one is gonna be the orifice and this one is gonna be the culvert, which okay, in this case I have to change
I
this.
mean, but aren't they both culverts?
They find, yeah, they are like culverts, yes. It is only the size.
So what's the difference?
This is
Like,
just a
like
terminology.
why can't you just do both as culverts?
Yeah, I could do that too. Yes.
It's just a description to
Yes.
change what,
Yes.
so it's not confusing
Okay.
for us.
Yeah.
And it's just also the weir needs to be routed to the one that's, so now I think it.
So
um,
I need to change it now. I need to change it now since I changed the size. This is number one, which is in our case it's gonna be 6-inch pipe, and then this is gonna be our 36-inch pipe, and it is related to this weir. So I need to fix it
But
as such. Yes, David.
okay, cause the description is confusing a little bit. I think when you call it orifice, because when you do orifice and culvert, there are different
This is just a terminology. I don't think it's gonna do anything. You set up things here, and let me see for this one.
but you see how we got different prescriptions and everything.
Yes, I see what you mean. So we can make it as we can
Cause
make it as
isn't an orifice just like a cutout
yes.
with a with
In the
like
vertical, that's what we said. In the vertical, you see here on the vertical plane, it is cut.
Yeah, it's just a name, so we can name it whatever, but I think I guess we would need to look at the calculation, but so I would
Yeah.
what to confirm it works, this culvert or whichever one is the larger pipe, it would need to show that there's no flow in it up until the weir elevation is exceeded.
Yes.
So in this case, 230, like we shouldn't see any flow until above 236 in that
Yes.
culvert. So I'm not sure
Yeah.
if it'll
So I
do
need
when we run it, if it's actually going to show that or
let's
not.
run.
I'm not
Let's
sure.
run. I need to change this though to device 2 now.
what can
So let's run it. Here it is. So the inflow is 28. I'm gonna change it into 2D. You see that is 1.19 inch to the primary.
But do we
So
we
we
need
have it. We have it the
do you have
opposite.
if you could click the discharge tab, does it give you a like headwater elevation versus discharge like table or somewhere?
I mean
Not
this.
sure where it would be, but maybe in the top
Let's
the
see
discharge.
here. No. Here is
So yeah, the
the
elevation.
weir.
So
Yeah, at
so
236.
primary. Okay, so that's right. So secondary. I'm not sure. I'm guessing secondary. Yeah, secondary is the bigger pipe. Okay, so it's not starting until 236.
Yeah.
Okay, so that's correct then. So David, this is how we need to do new Windsor. I think we already maybe fixed it this way, but
Okay.
okay.
so like
Yes.
the orifice needs to drain to the larger pipe is what the bypass pipe, in our case, that 28-inch steel.
Okay,
Okay.
yeah. I think that's what I did. Yeah, so
Okay. We can talk about it if you want to.
okay.
Yeah.
Hmm.
So now I diverted some flow to the primary. Let me make it 2D. 28.5 is coming in, and 27.33 is going to this band, and only 1.9 CFS is going to this. So if I now run this, actually the opposite, it is this 1.19 CFS is coming in.
Oh,
So
okay, got you.
so I need to change it in such a way that I can do this thing.
Okay.
Yes. You see, now 27.33 coming in now to this band.
Mm-hmm.
And 4.15 is coming out because I have some storage here and some. And then here, now it is correct. You see 1.19 CFS is coming in here, and then 0.9195 is coming out at 6 inch around culvert. So this is the way how we should set it up before. It makes sense now?
Yeah.
So from here, the total is 28.53. 27.33 is coming here, which is the secondary. And then it is hidden here, but if I make it 2D, 1.19 CFS is coming to here. We can play with it. Okay, any questions?
So when you clicked on that ESD,
Yes.
I think it showed two numbers, right? One was what was coming in,
Yes.
and I think you mentioned what's going out.
Yes,
So are you?
0.95.
Yeah. So is that also being routed through that ESD, whatever that is?
Yeah, because I have some storage here defined.
Okay. Okay.
Here I have the ESD, some storage. You see here?
Mm-hmm.
So it is, I have I put some storage here. I think I have some outlet also here, some culvert here.
So
So it is,
there is
which
a
is,
control structure there.
yes.
Okay.
Yeah. So, 28 is coming out of this. And then 27 it is divided into 27.33 and how much was that? 1.19. And then here, that 27.33 is coming in. And then, of course, I have some storage there. I mean, some management there. So only 4.15 is coming out.
So if you click on catch basin 6P,
Yes.
so there are 3 or 4. I think I saw 4 discharges.
No,
No, just 3.
I don't think. Yeah, should be
Okay.
3. Let me change this. This is 28.53 is coming in.
Yeah.
And this is the total outflow
Okay. Okay. So
because it
it's the
doesn't have
same.
any storage. If
Okay.
you
Yeah.
add these two numbers, I see what you mean. If you add
Yeah.
this 1.19 and
Mhm.
27.33, it's gonna be the total 28.53.
So each node, it will always give you what's coming in and what's going out.
Yes.
Okay.
Yes. So now for this reach, I define some parameters here. I define this cross section based on these numbers. That I just define the cross section of a reach, a channel, and then here you put also the longitudinal, and the profile of that channel. Here I have the length of that channel is 200, the invert, the upstream 190, the downstream 180, and I just put 0.015 for Mannings, and this is automatically calculated the slope for me. So if I click on it, you see, again, only 5.10 CFS is coming in. Something from here, something from here. I think this was 4 point something, and this one was 0.95. And then, of course, there is no attenuation here. So the outflow will be the same also, 5.1, because it is just a reach. And On this pond, I put some, here I have storage. You find storage. And then here are the outlets. David, you asked me last time about embankment. So here is how you define it. This one is for the riser. This culvert is for the riser. I call it primary. And these are the weirs on the sides of the sides of the riser, because you see this weir is routed to device 1, and device 1 is this. You see this number 1, 2, 3. So, and then I have also another at a different elevation, another weirs, which are, it looks like 2 of them. You see 2 of them at this elevation, and this is the discharge multiplier. I can make it 4 if I want to, but you can make it also 1. So I have that on the vertical plane again. That means on the vertical surface, the weir is gonna be, if I make it horizontal, that is gonna be the top of the riser. And I have to define the elevation as such, but this is on vertical on the wall, and these are the sizes of those weirs. So again, these 2 weirs are routed to the primary because it says device 1, and my device 1 is the culvert. And if I want embankment, I mean emergency spillway or something, I'm gonna define it separately, and it's gonna be by its own. It's gonna have its own parameter. This is the length. This is the breadth. You see, it tells you which direction is that parameter. When you go this, the length is perpendicular to the flow, and the crest, the breadth is along the direction of the flow. Again, you have multiplier. If you have 2 or 3, you can change it here. This will be calculated for you based on what you put here. Here, if I make it now to device 1, it's not going to be embankment. It's going to be routed to culverts. So that's why I put it as primary, because it is independent. So that's how we define the emergency spillway or something.
Can you go back to that embankment?
Here?
Yeah.
Okay.
So on the right hand side, you have head and
Yes.
seed.
Yes. This is because it is broad crusted. If it is
Oh, your seed coefficient changes with
yes,
the head.
yes,
Okay, got it.
yes. So now for the, do I have time? Yes. For the damp reach analysis, we just create here, what we do is we just create hydrograph, which we are gonna insert into HECRAS. So the way how you do it is, there is an option. You see damp reach here? You can choose that. That's how I did this. And then you're gonna put the parameters here. So the top embankment elevation is 237, and the bottom is the storage begins at 214. So that's where I say where the bridge is gonna start at 237.57, because when I run this without the dam bridge, I found the maximum elevation, water surface elevation, 237.57. That's how I set up the start elevation of the bridge. And the bottom is gonna be 214, because there is my storage begins there. You see 240, and it goes up to 238. I put some more storage to continue with the calculation. So 237, the top embankment, 214, the bottom of that pond. And the bridge height is, of course, this minus this, which is 23. This is gonna be calculated by some method, the angle. And the bridge time, I put 0.17 hours. These are another parameters which you can calculate with something else. Once you put here, it's gonna generate for you. It's gonna generate for you the hydrograph. This hydrograph, and then you're gonna use this hydrograph. You're gonna copy this hydrograph based on the time, and put it in HECRAS. And this I think we mentioned this bold means there is a maximum between these two. So if I click, you see here between 13 and 14, no, yeah, between 13 and 14 is some maximum. So to see that what that maximum is, you just unshrink it. Between 30, did I say 13? Yeah, here between 13 and 14 is going to be some maximum. So this is how you see the true maximum. Somewhere here is going to be, you see here they are now, only one bolt. So it is 4.15 for this. I don't know what that is. For the primary, 4.15 because I'm running only the 100 year. But if I run, I think I have, do I have? I don't have it here, but we can set up, I do something here. If I put that, for the bridge, the rainfall event with 6 hours, maybe it is 14 inches per 6 hour, something like that. But the way how you set it up is like this. So at the outlet, dam bridge, the top embankment, the bottom of that pond, and then this is calculated because this is the difference between this and this, 23 feet. This one, as I said, I'm gonna, what I did was I just ran this configuration for that rainfall event without a bridge, and find the maximum water surface elevation, and that's how I found this number. And then the bridge time, also, of course, there are some spreadsheets from MDE how to calculate. MDE wants 0.17 minimum. And then this, the weir coefficient also. And then what you find from here, you put it as a hydrograph input for the HECRAS to use it in the HECRAS 2D. Any questions? Of course, you can copy and paste if you wanna. Oh, sorry. If you wanna copy and create the same, these and these are now exactly the same. And you can also put some, instead of going directly to this, what I want to do is I'm gonna copy this and paste it so that I have another diversion to another ESD practice. So what I can do is now the diverted flow from here It's gonna come to here, and then I'm gonna copy also this another ESD facility. Sorry. We can set it up like that. Sorry. This is ESD, so this is gonna come on, to here. We can do that too. So the diverted flow comes to another catch basin, and then I want another ESD practice, so some flow will go there, and then the rest will come here. I can do as much as I want diversion based on how
So
many. Yes.
this only is valid if you're not diverting all 2.6 inches to the first ESD.
Yeah.
So
I
if you-
mean, no.
I mean, if
What?
you're already like diverting all your water quality and CPV to ESD1, then you can't
Yes,
treat more than
yes,
2.6.
yes, I understand. Yes. I mean, I'm not sure if we can do 3 times here, so this is the way how I did. So maybe from here also we can we redirect here, you see, for quantity purpose maybe. Any questions? I tried to go as fast as possible because I wanted to cover everything what we missed last time.
Just one thing is there any way to, for example, so like when we're getting back to this flow splitter, the weir flow, we're assuming like a free outfall kind of condition, like that the actual, and I think we used a 4-inch pipe in this case, but like that 4-inch pipe won't have any problem draining whatever, it needs to drain. But is there any way to like input like the impacts of like a hydraulic grade line? So for example, like in our project, the pond is we can't lower it too much lower than the outfall invert of that 4 inch, whatever size pipe, but that for in this case the 4-inch pipe. So the county asked us to evaluate it with with that in mind, with putting an HGL, like 10-year HGL, and kind of making
Like,
sure it'll flow.
I'm not, I didn't do that, so I am not aware. Are you talking about tailwater effect or?
Yeah,
Yeah,
essentially,
you
like
can,
to make sure it's gonna actually go. Like,
here you can put whatever tailwater, either fixed, you
okay,
can put
so you
elevation.
can, so they're selected as free discharge, but
If you, for a discharge, then there is no tailwater, that means. But if you have
yeah,
some tailwater elevation here, you can put it, or you can change your calculation here, your calculation method into dynamic. That means the tailwater elevation is gonna be, not gonna be constant. It's gonna be changing based on the situation. So this one can let you change, the way how you can route. We had it store indication. That means we're gonna have either pre-discharge or fixed, and this automatic will come on if I change the routing method into dynamic. Let's see. You see? That means
so
it's
dynamic. I'm not sure what dynamic. So okay, so
dynamic means, the tailwater is not constant.
Okay, so then that'll be like more accurate. It just
Yeah.
if your outlet is, you know, somewhat not too much above the permanent pool elevation or whatever.
Yeah.
Um, okay.
So you
And-
go to setting here, and the calculation, you change the settings. So I changed the pond routing method into dynamic storage indication, they call it, and that will allow you to account for, variable tailwater elevation
Okay.
So how would we define that tailwater? Like, how does it know the tailwater is changing?
based on because of this.
The pond, like it'll generate
But
the water surface elevations of the pond, right?
Yes.
okay, so if I understand correctly, Ankur, the the diversion pipe is currently outfalling below the permanent pool elevation of the pond. Is that the reason why county is asking us to take that into
It's
account?
not below, but it's like right at the permanent pool. So, and we don't have
Okay.
much slope on that pipe. We can't
Uh-huh.
put that much slope, so that's why they're saying consider the friction losses in that pipe essentially. Um,
Can you just use a bigger pipe to counteract that? Like,
yeah, it's just that pipe. It's it's just a tight situation. Like the pipe in the riser is the top of the riser has a constraint just based on topography, so we're butting up against that as well. We
okay.
need to put like an elliptical pipe or something, but yeah, I mean we can put whatever size. It's just they still want us to show you know that
Mhm.
size is fine. So
Okay.
what's happening is we have a separate HCL calculation to get that, but then this HydroCAD also in their documentation it says that they don't explicitly calculate the HCL, but they give you like the elevations at each of the structures based on whatever design storm you select. So it kind of has like those elevations and in their guidance it says you can use them as HCL, but it's not like the same because it doesn't calculate the friction losses and all those the
Yeah.
losses the same way.
Mhm.
But so I'm not sure if jurisdictions will like kind of accept it that way or not. That's actually one question I need to ask county, but um, I think we need to, David, I think we need to change it to this dynamic storage. And I think that'll help. That'll give me something to say to the county that, you know, it is being considered, but I'm hoping they'll just let me do it based on the elevations that HydroCAD gives us, so we can just get rid of the HCL calculation. But I, I need to check that just because the elevations are a little bit different depending on how you calculate it. Um, yeah, anyways, that's just like specific to this project, but if you have similar where you're working with tight, you don't have enough elevation drop essentially, then you know, that's something that the reviewer may ask for.
Okay.
Yep, that's helpful, Solomon. Thank you. I
Thank
think,
you.
yeah, and because there's no need for TR20 then, right? Because you were
Yeah.
putting the pond itself in there, so it'll
Yeah.
give you discharges
Everything is
out.
here.
And,
Yeah. TR55, TR20 is here. So I talked to Mahendra about the license because only one person can use it right now. Last time I tried to share with David, and we couldn't use it at the same time. So I talked to Mahendra about getting more licenses for this thing.
Yeah, I'm in coordination with the Rick. He's going to check with the company. We must have 2 to 3 licenses. There may be some link or something we need to receive from the company. If not, I will request to buy at least 3
Yeah.
these softwares because only one is not very useful. We will be using this extensively.
Yeah. We don't have to do two things, like what we are doing right now. WinTR20 and WinTR55, everything at the same time. And it is easily manipulative also. You can manipulate everything here. You can see what you are doing on HydroCAD.
Yeah, we'll also need to check if NDOT will accept it, right?
Yes, that is another. MDE accept it, I know.
Right.
Yeah. I mean, it's pretty common one, so I think so,
Yeah.
but a lot of them just have that text like proprietary software may not be accepted or something. It's just if the reviewers are familiar with looking at it,
Mhm.
kind of thing.
Right. Any questions? Anybody, please ask Solomon. You have around 9 minutes to ask the question. Okay. Thank you. Solomon, do you think you need another session for to cover rest of the things?
I think we did everything. If somebody has question, like
Yeah.
I'm very happy to share what I know.
Yeah, looks like right now nobody has questions, but any questions, please email Solomon and or talk to Solomon while designing a project. If you have any issues, do not wait. Go to Solomon or Ankur, Arun, whoever, and then try to resolve as early as possible. Do not guess estimate, otherwise that will kill the time and quality. So thank you, Solomon, for your presentation.
Thank
Have a
you.
good day, everybody. Thanks. Bye.
Thank you.
Thanks.